Hello everybody and welcome to this session of Node.js. Today we will have a look at Node.js but as a HTTP server. So a word about Odin School. Odin School is a technology upskilling platform. We help you continuously acquire new skills. So stay skilled and stay ahead. Well guys, my name is Vijay Makhija. I started my career around 2010. Initially, I was working on PHP based websites. I worked on WordPress, Magento, CodeIgniter, which is a PHP framework. But in the past few years, I've slowly shifted more towards totally JavaScript based development in front end and in back end. Earlier, I used to work on, like, I did start with jQuery, um, worked on responsive websites, used frameworks like Bootstrap. But over the past few years, I've moved to modern front-end frameworks. The most I've worked on is React. Also tried my hands on Vue and Angular. Apart from web development, I've also worked on Chrome extensions and chatbots. Before starting, let's understand why we should learn Node.js. Well, reason one is this tweet from a guy called Jason Mays. He works at Google. I don't know why Twitter isn't loading today. It might be down. So, well, actually, this is the image which he had posted saying JavaScript made it to space. So, SpaceX recently launched one of their missions, and they used JavaScript to create this control panel kind of thing in their rocket or spaceship. Well, there is even this Reddit AMA, which is Reddit Ask Me Anything AMA. The AMAs are very pretty fun, pretty informative. Also, you will find AMAs from many people, even the creator of Node.js, Ryan. So you might want to have a look at that. It's a pretty long discussion. So AMAs basically are where anybody can ask anything to, let's say, so this is AMA for the SpaceX software team. So if you search for JavaScript over here, they would say that, yeah, like we use. So they say the crew displays onboard Dragon runs Chromium. So Chromium is the project on which the Chrome browser is built, and that Chromium project is also used for desktop applications. So yeah, they do use JavaScript, and people have asked them some other couple of questions regarding JavaScript and other things. So yeah, so this is basically what they were talking about, that they built on top of Chromium. So yeah, JavaScript is everywhere, not only in front end but back end in the form of Node, and then Node is used everywhere. So even in front end development, you will be using Node for creating your builds, creating your projects, managing them. In the back end, Node is used as a server pretty much by many companies these days. Even for desktop applications, Node is being used these days. For example, there is this project called Electron. Okay, so Electron is basically used to create desktop applications, but using web technologies, so JavaScript, HTML, and CSS. And there are many projects created using Electron. One of the most, what do you say, very in DevTools community, one of the most loved ones these days is Visual Studio Code, which is basically a project created using. So you can see here Electron, Chrome, and Node. So Visual Studio Code itself is built on these technologies. Uh, so yeah, JavaScript is everywhere in front end, back end, desktop, all over the world, and also in space. Another reason, if you look at Google Trends, so Node was created around 2009, 2010. So since then, you can see has been a constant upward trend. If you compare that with, let's say, PHP or Java, PHP started around like 1995, I guess, and Java was, I think, almost 5-6 years before that. So PHP is almost 25-26 years old. It has the data since 2004, but you can see a constant downward trend for PHP and Java. And I'm not saying PHP and Java are not used, but they are. But you can see the trend. It's not an upward trend clearly. Node is hardly 10 years old, but there is clearly a upward trend in Node that we saw. Another reason, which is one of the main reasons, is the performance of Node.js. So Java, as we know, is a compiled language, but still, if we want to compare, so this page on Debian.net, the computer language benchmarks game, is basically what they do is there are different set of algorithms, so they implement the different algorithms in different languages and then compare the performance of different languages. So here I think they've pretty much covered all major languages that there are out there. So if you compare, let's say, JavaScript, so they haven't named it Node.js outside, it's actually Node.js if you open the page. So you can compare Node.js and Java. Node.js is a scripted language, it's an interpreted language. Java is a compiled language, but still, if you see, Node.js wins in two categories. It's pretty close in some of the categories, in some of the performances. Okay, and yeah, there is this one, two, yeah, 2-3 places where I would say, okay, there is here there's a huge margin, but then other places the margin isn't that high. If you compare, well, a reasonable comparison would be comparing scripting language with a scripting language. So comparing PHP and Node.js, so PHP wins in two areas, and then in rest of the areas Node.js is a clear winner, and at places Node.js even has wins by a huge margin. Similarly, we should be comparing Python also, because Python is also very popular these days, used in many areas, mainly data science, ML, AI, and also web development. So yeah, Python again kind of wins in two categories, two benchmark performances, but then in other places Node.js is a clear winner, and at places with huge margin. So Node.js is faster, Node.js is everywhere, mm, literally everywhere. Also, it's used by many companies these days. I would like to highlight this one company, Netflix. Everybody knows Netflix these days. Almost, I read in some blog somewhere that almost 20 to 25% of the internet traffic today is is Netflix. And Netflix does use Node in their technology stack. So this is the official Netflix tech blog. If you search for the keyword Node, you would see their blog posts on Node. See how they are using, how they have scaled it, etc., etc. Also, NASA, PayPal, they use it. So if you search for this OpenJSF NASA Node case study, so OpenJSF means Open JavaScript Foundation, NASA Node case study, you would find this link. It's a PDF document explaining how NASA is using Node.js for getting some spacesuit data, which is like mission critical and also critical for, it's like a life and death situation for the astronauts. That data is crucial for the spacesuit, and how they are using Node to get it even faster. So yeah, it's a pretty interesting read if you want. So pretty clear why to learn Node.js. You should always be clear on the why part. Okay, what and how are the easier parts. Why is where you should be clear always. So enough about me, let's start. The agenda for today is, we'll understand HTTP basics. We'll have a look at the HTTP module in Node.js, and then we'll have an introduction to Node frameworks, and we'll try a hands-on of the Express framework. So HTTP. What's HTTP? HTTP, it stands for Hypertext Transfer Protocol. Okay, but then what is hypertext? Well, to answer that, let's open this link. Sorry. So this is a page, okay, a very old page, okay. It defines what is hypertext. So hypertext is text which is not constrained to be linear. Hypertext is text which contains links to other texts. The term was coined by Ted Nelson around 1965. 1965, okay, most of us, like even me, I wasn't even born back then. So this is basically hypertext. So initially the way HTTP was created and defined was, basically to have documents on the internet, and documents could be connected with each other, in any way we want, just using links. Initially, even the first browser, that was the Mosaic browser, did not have any media, like did not have image, or it was just text with links, you know excuse me. So that's basically what hypertext is. And what we want to understand is hypertext transfer protocol. Protocol is what? A set of rules. So what basically they did create was a set of rules to transfer hypertext, transfer between a browser and a server, or a client and a server. That's basically what HTTP is. So if a company or an organization decides that, hey, we want to create a browser, like Google wants to create Chrome, or Mozilla creates Firefox or Opera, and on the other side, let's say there are companies who wants to create, or organization that wants to create a server, for example Apache or Nginx or IIS, by Microsoft. So they have to refer to the specification for the HTTP, the specification for transferring hypertext between a client and a server, or a browser and a server. Yep. So w3.org, that's like the official documentation of the web, okay, worldwideweb.org. So in a way, this page actually defines in detail what the specifications should be for hypertext transfer protocol. Okay. So basically, what there is a request and there is a response. A request goes from a browser. These days it can be anything from desktop to tablet to a cell phone, using a browser or even an application. Okay, it's not that only browsers can make a HTTP request. Any application can also use HTTP protocol and make a HTTP request. So a request is sent to a server, and server basically responds back with some data which the device shows you. So what is sent in the request? Well, basically it's a few things. Few things go in the request, few things come back as a response. One for the request, one is the method, then there is the path, headers, body. Well, viewing that is pretty easy. You can even open google.com. Okay, once you have any web page open, just right click anywhere on the page, open inspect, or you can press F12, or you can press Ctrl Shift J. Okay, let me zoom that for you. Come to the network tab. Okay, I've zoomed in. So in the network tab, once you are in the network tab, refresh your page. So to load this page, these are all the requests that this browser made to the Google server. Okay, these are all the requests made, different kinds. There are images, there is simple text HTML, there is JavaScript. Okay, so different kinds of requests made to the Google server. If you click on any of these, so let's say if I click on this main google.com one, if I click on this and go to the headers tab, okay, so there are mainly three sections: the request headers, response headers, and general. So if you look at the request headers, this is what is meant by header. So this is information. So so in the request, the first part is the URL google.com. That's what I want to open. Along with that, browser also sends these extra things. Okay, a common ones being like cookie. They send cookies, which is like data stored in your browser for each website. User agent basically tells the server what kind of browser and what kind of operating system the request is coming from. And there can be many, and yes, another main one is method. There are a couple of methods in HTTP. There is get, post. So anytime you open a web page, simply that's simply a get request. If you're submitting a form, that's typically a post or let's say you're uploading a file or submitting a form, that's typically a post request. Apart from that, there are other HTTP methods as well, like head, put, delete. But the most common ones generally use most of the times are get and post. And then there is the path. Okay, so I opened google.com slash nothing. Okay, let's say I try to open slash images. Oh, sorry, image. Okay, images. IMAGES. Okay, so it redirects to some other URL. Okay, that's okay, that's fine. So as you can see, the path is also set. So I did open slash images, but then it redirected me to IMGHP. So that's the image search page of Google. So all this goes in request. All this goes as a request to the server. When server sends a response back, so one of the things that you get in the response is, well, the page itself. So the HTML. Okay, in case it's when you're requesting for a page, obviously you'll get the page HTML. Okay, and this HTML page might have, JavaScript or links to CSS or images. All once this page is received, all these script tags or CSS links or images, a separate request for all of those is again sent to the server, which you see here. Okay, so this PNG image again would be somewhere in this HTML. So browser gets the HTML, it sees, okay, I need to get all these things as well, and then again new requests are made for those resources as well. So this is mainly the response. Apart from the response, we also get response headers. In the response headers, we get content length. So this is the size in bytes, the type of content, which is called the MIME types, or multi-purpose internet mail extensions if you want, MIME type. So yeah, it's pretty straightforward. Is for HTML it is text slash HTML. For JavaScript it is text slash JavaScript. For image it depends, image slash PNG, image slash JPEG, things like that. And there are other things, other information can be there. For example, what kind of server it is, cookie, it can set a cookie in your browser. So cookies can come in a response from the server. Also, we get the status code. Well, for pages, usually it is 200 if the page opens successfully. 200 is success code. 302 was basically for like the page opened from the cache. It wasn't loaded totally from the server. Yeah, so there are different status codes as well. The most common one everyone might know is 404, where page not found. That's 404. So 200 is for success, 404 is for when uh, a resource or the page is not found. 500 or 503, all those are for server errors, where something went wrong on the server. A status code 100 you might never see, because that's when the request is still in progress. So you have mainly 5 kinds of codes. One can be in the series of 100, then 200, 300, 400, 500. Common ones you see: 200 for success, 400 when not found, 500 when there is a server error, 300 when it is like loaded from the cache, something like that. Okay, so also in the request there can be a body. that's when you're actually making a post request. For example, you're filling a form. Okay, that's when you also, so for example, if I search for, so I searched for Odin School. Okay, but here it's not a post request, it's usually a get request. Okay, but then again, even in the get request we can send data to the server by passing data in the URL. So after a question mark, we can pass in our data, like source equal to HP ampersand EI equal to this code ampersand. That's how you send data from the URL itself, and you can see that in here in query string parameters. Okay, and our request is over here, Odin School Q, that's query equal to Odin School. Okay, so that's one way of sending data. Another way of sending data to the server is using a post request, which we will have a look later. So basically you get the idea. So this is basically what HTTP is. No matter what front end or what back end you're using, what server or what browser you're using, this is the fundamental. This is like the HTTP specification. This is how HTTP should work. No matter what browser, what server, what language, what platform you're using. Okay, so this is the basics, the fundamentals. So now talking about HTTP module in Node.js. So we had a brief look at HTTP yesterday in the built-in modules part of Node.js. So HTTP is a module that you can use in Node.js. Okay, you can open the documentation, have a look. Many kinds of methods. So this is where they explain. This is the like official documentation by Node.js of the whole module. Every method is listed over here. You can look at the methods, what they do. So basically this is the main purpose of HTTP module, or mainly where HTTP module is used in Node these days. Node can do a lot of things. Creating HTTP server is one of them, but that's the most popular way. Okay, and as I told you earlier, Node is used even in desktop, the creation of desktop software, using Electron or tools similar to that. um, Also creating front end, even in front end Node is used for build tools and many other things, but this is like the most popular thing why Node is used as a server. Okay, you don't need a separate server like Apache or IIS or Nginx. Node itself will create a server for you. Okay, like if you're working with PHP, you need a, let's say, Apache or Nginx server. If you're working in .NET, you need a IIS server, but in Node itself creates a server for you with just a few lines of code. So you import the HTTP module, your host name is 127.0.0.1 or localhost port number, you can give 8080 8888, any number like that. And with this line http.create server, you actually create a server that will take incoming requests from the browser and then send a response to them. Okay, as simple as that. And server.listen, this fire, so this callback gets called once when the server starts. Okay, and if we get this message, hey, the server is running at this URL and the port, fine, your server got created and it's working. And every time you get a request, this function gets called. Okay, we'll try this out in hands-on as well, but before that, now this code is from Python. What I want to explain you is, if you look at this part over here, this function, okay, this callback function that we pass into create server, this function gets two arguments, request and response. So now we know what falls under request. Request has the URL, the paths, the method, the request headers and stuff like. So whatever came from the browser, whatever I showed you in this dev tools. Okay, so all these request headers, the request method, the URL, the path, everything. If you want to access all that data, you have the request object. You can do all that. Okay, you can see what all headers you received, what query parameters you received, what was the method used for the request, and response is what, as a developer, you would use to send the response to the browser, and that response obviously would contain actual data or the HTML page to be sent. Along with that, you can send the response headers as well. Set the page content type. By default, it would be text HTML. You can send plain text. You can send JavaScript. You can send CSS, any or JSON. So any kind of data you can send. So those are also, you can send the status code in case there is an error. You can send the status code, let's say 500. So browser would know there is an error. Okay. So now this request response object that we get and request, we can access everything that browser had sent us. We can know everything, parameters, headers, this, that, everything. Response we can use to send the response data like HTML, JSON, JavaScript, set the cookies, etc., etc. It is not something special only in Node.js, no, but no matter which language you use for server-side programming, let's say, so this example is from Python. Okay, so this is basically a simple example of again server-side code uh, where def is like the way we define a function. This is the function name, and we get the request object even here as well. So this basically means that the function whatever you place over here, um, let's say template, or let's say about, let's say you have a page called about, so your website name.com/about, imagine about over here. So this basically says that browser can send a get request or a post request to this, and then you get the request object over here as well. You can check whether the request method is get or post, and then also use the response object to send the data. Okay, so this is Python. This is Java. Okay, in Java you have HTTP servlets, and whatever your class name is, you can actually use that class name, uh, pair it with a URL or a route. So whenever that route, or like website name.com/about is called, this class will get called, or the corresponding method will get called. So if it was a get request, this do get method would get called, and if it was a post request, this method would get called. And look here, even here you get the request and the response objects. And similarly in Java as well, request and response objects can be used like to access all the request data that came from the browser, and use the response to send a response to the browser. Okay, so what I'm trying to make you understand is, so no matter which language, which platform you work on, because HTTP is a protocol, or is a specification for browsers and for servers, that hey, if you, or any client and a server, that hey, if you want to transfer data using HTTP, this is the way to do it. And that is why you will find a lot of similarity, the way things work on the server, like in any language, and in the browser as well. Okay, so request response, that's common everywhere, no matter which language you work on. Okay, so we understand request response, we get the idea. Now the code that I showed you was, yeah, the code that I showed you, this is creating a simple HTTP server using only the core Node.js code, nothing extra. Okay, so let's try this out. Okay, Instead of typing this code, so there are two websites in Node.js I would have shown you earlier, but the old site was nodejs.org, and the new site they created is nodejs.dev. So if you go to learn section over here, an application would load. So I'll just copy the code from there. Okay, I have the code. Okay, so here as you can see, we're using the response object to set the response status code to 200. We're setting a header, a response header. We're saying that hey, content type is text/plain, so it's not HTML, it's just plain text. Okay, but let's try it out. You can open terminal from here, a new terminal, or you can use another tool, for example Hyper. I think I had shown Hyper I think two sessions ago. Let me zoom this as well. So if you get bored with the CMD, you can even use Hyper. Also, a cool thing about Hyper is, oops, sorry. This is also created using, I think, Electron developer tools. See something, so it's just like Chrome. So this is also like built upon the Chromium project. So a tool like this which emulates your CMD or terminal. So even Hyper is built like this. It's a nice tool if you get bored from the normal CMD. So let me go to this directory. The way to run this simple, type in node and the name of your file. So we got this line running, server running add http. Okay, now when I open this URL, let's see what happens. We get hello world. Let me do the inspect element. I'll open the network tab. I'll do a refresh. Browser, most of the browser these days, they by default make a request to the root of your website searching for favicon.ico. That's the icon that you see over here. Okay, so don't worry about that. So once you click on this, you see all the request response things that I told you about. So in response headers, if you see, we have content type as text/plain. So why is that important? Let's say I want a heading tag. I want hello world to be big. Okay, now I changed my code and I refresh. I don't see the changes because I need to restart my server. So Control C for ending stopping the server. Start again and refresh. Still I see the code. Okay, you can just click on view source and see that okay, we get the source right. You even see line number 2 over here. Okay, that's because we had a /n at the end. Okay, but I don't see the actual HTML. That's because the content type is text plain. So what we are saying in the response header that hey, no matter what data you get, show it as plain text. Okay, if we don't set this, browsers these days are pretty powerful. They detect the kind of content coming from the server. So if I don't have any of this, browser would still have status code 200 and set the header to text HTML. So I change the code. I need to rerun my server. I do a refresh. Voila, there you have it. Hello world, big H1 tags. Status is 200. Okay, status is 200. Method is get. That's the default. Whenever you're requesting for a URL, by default the method is get. Okay, it's only when like you submit a form, upload a file, that those are the cases where they actually use a post request. Okay, so the request object will have uh, I think the method property. Okay, you can refer to the documentation, everything. So if I go for not the agent, client request. Yep. So HTTP methods. Sorry, hold on. Yep. So here we are. Uh, so we get the request.path, where we will know the path requested. Request.method will give us the method. For example, if it was get or post, host will give us the host name. Protocol would give us the protocol. It can be HTTP, HTTPS. So we have the request object, a couple of methods and properties. Similarly, in the response object, we have many methods and properties. For example, response.end. So response.end means that's where actually uh, the node sends the response to the browser. You can't send anything after this point. Okay, so that's what response.end is. You can even set the headers. You have the set header property method that we used here. You can use response write. So what we can do is so let's say I start this hello and end with a world. Do something like this. Okay, let me try. So we got the method and we get the get two times because another request was made by the browser to the server searching for favicon.ico, but we don't have that, so that's why we get the two gets. So we know this was called twice, and we get the hello world. So this is where our response ends. We can't send any response after this point, but before this you can have n number of write statements. Okay, yep, you wouldn't even know how this was sent. So yep, there you have it. To demo a post request, what I can do is can create a form with the method post. Sorry, action with the URL, and then I create a button. Okay, and I open this HTML. Okay, so it basically has this one form with a button. That's it. And when I click on this, the form, okay, I made a typo, method. And when I click on this, the form would submit using method post and submit to this page. I clicked on submit and this page is now open, but when you click on the network tab and you uh, open this page, you see that the request method was post. Okay, over here you see the method was post, but then but all the subsequent requests that this page makes to get all the images or the JavaScript or the CSS or things like that, for that again the method is simple get. Okay, so I can simply write something like this. Okay, so this was a get request, this was a post request, as simple as that. Let me stop the server, start again. I'll refresh this. I refreshed this page and I got this was a post request. I did not submit the form. Okay, I had submitted the form earlier and then landed on this page. I restarted my server. I did a refresh. Whenever you refresh in a browser, your last action happens again. So my last action was submitting that page, that button, that form. So that action actually got repeated. So refresh doesn't simply mean open the page again. No, it repeats whatever last action that user did. Okay, and if there was no, if you just opened the link and you came to the page, that's a simple get request, as good as opening that page by entering the URL in the browser. So refresh simply does that. It actually just opens that page because that's what your last action was. Okay, so remember the refresh is uh, it's not that simple. Okay, it redoes whatever the last action the user did. So this was a post request, but if I just click over here and I press enter, this was a get request, as simple as that. Okay, we also have the path property. Let's see what path gives us. So I'll run again. So path is undefined. If I say slash about, undefined. Okay, so how do we get the path? So this is where you refer to the documentation. Request.path. Okay, that's how you get it, right? But we're getting it as undefined. Why? Request.path. Are we missing anything? Let's check. Did we restart or no? Let's check again. Console request dot. Let me just console log the request object. We'll come to know. Let's see what we get now. Run again. So we get this though, it's a huge object. And I'm seeing, do we get the path or not? Documentation says we have the path property, but it shows as undefined. That's what we want to know. So request.headers. Okay. I'm doing this because in a way, whenever you're working in the real world, a lot of your time is basically debugging, doing this, going through the documentation, check why things are not working. Okay. So there are times where even simple things don't work. You might be missing some simple thing. Okay. But that's okay. That's a part of your job. You have to go through that grind. Okay, request.url. I think that's the one. It's not path, it's URL. Let's see. Is it small case or? Yep, I think so. Status. Okay. Let's try that. Request.url. I think that's the one. So now you know one issue with Hyper, we don't have a scroll bar. I have to scroll till the end. Okay, I'm at the end now. Let's refresh. Okay, great. I think this is the one. Let's say /about. Yep, I get that. So great. We can use this now. So basically, the way you can do is you can actually like do something like this, where you set an if else and declare the routes of your pages. So let's say you have 5 pages, so you would have 5 if else ifs, and in the end, in the else, you can say like 404 page not found, something like that. Okay, and you can even set the status code in that case. Okay, so I can set the status as 404 for this. For the home page, I'll say this was a request for home page. So now you get the idea how things work. Okay, I'm not doing it for post, I'm only doing it for the get request. Okay, so you set your routes or your page URLs over here. Okay, let's restart. Refresh. This was a request for the about page. So now you see favicon.ico, we get a 404. Okay, because for for about and for just the home page we do have a response. Okay, but for others we don't. Okay, so let's say anything if I type, it's a 404 page not found. Let's try and see if we pass something in the URL. So question mark x equal to 123. So again, this is not parsed because that .url gives us the whole thing. Okay, so then again, now you get the picture. We have to like write extra code, separate this what do you say, this I think the path, let's console log the path again. And I'll add a simple line in the end, so we can separate things like for one request. Let's restart our server and let's request again. Yeah, okay, so you get the picture. So again, we'll have to write code to separate this, separate all the URL parameters, and then so you get an idea how things work. So now you understand get, you understand post, you understand the paths or the URL, stuff like that. Okay, moving on. Now let's say you wanted to write a actual web application, or let's say a REST API or anything. You wouldn't actually do it in just the vanilla or out of the box, the Node way, but you would actually use a Node.js framework. So if you go to nodejs.dev to the learn page, and if you scroll down, even just in the first introduction part, so there are a couple of frameworks listed over here: Adonis.js, Express, Fastify, Happy, Koa, Loopback, Meteor. I won't open all of them. So yeah, so many, and most of them are open source. You'll get the GitHub link. So you have Adonis, there is Express. Where is the GitHub link? Okay, we'll open it ourselves. Fastify, GitHub, Happy. It's okay. Koa, do we have the GitHub? Nope. Loopback, GitHub. Meteor. Nice, they have nice Meteor animation. Any GitHub links? GitHub. So Adonis has where did it go? Yeah, 8.5k, so 8,500 stars. GitHub is, oh sorry, Express is 49,600 stars. 15,000 stars for Fastify, 3,000 for Strong, the Loopback, 41,000 for Meteor. Okay, so by stars alone we get a picture that, oh hey, Express and Meteor are very popular. Okay, others are also being used by many people, but if you're starting out, Express is the one used the most for uh, developing your web applications or REST APIs. Meteor is also, if not more, but I would say equally popular these days. So we will move on with Express and try to see how it works, and try a hands-on demo. Okay, so if you have not done till now, please download Node.js, download the LTS version, and basically we have 4 steps to follow. Okay, so I'll close this. I'll open the terminal. So we have server.js, but we were using it for like Node only, but now we have to create a project, npm project. Okay, mkdi, so we're not making a new directory, we'll just start with npm init. Okay, sorry, npm init. Okay, package name express demo, version 1 yes, description nothing, entry point server. I'll create a, let's say, index.js Okay, we won't touch server.js. People usually name their files like main.js or index.js or server.js whenever they're creating an application with Express. So we already have server.js. Let's not touch it. I'll create a new one, index.js. Test command, git repo, no keywords, no author, license, which is okay, yes. So we have a package.json ready. Everything that we listed. Okay, great. Next one, npm install express save. So express again it's just a npm package actually. So if you look at it on the npm site, okay, 14 million weekly downloads, so pretty popular. Okay, so how do we install it? Npm I express or npm install express. Okay, so that will install the express framework for us. It will create a node modules folder, install express and all of the modules on which express is depending on, all of them will be installed. Okay, that was pretty quick. So you see it's many npm packages that express depends on. Okay, let's create the index.js. Okay, and basically you start coding. So we'll take a simple example from here. So now you don't need actually the http module. All that things are handled by express in its own code. So you actually import the express module. So you create an express object out of that, and then you run that as a method. You create an app object, and then you just say app.get the path over here, and then again you'll have a callback function with request and response. These won't be exactly like the request and response objects that you get for the HTTP module. You will get everything, method, URL, this, that, everything, cookies. But there will be differences. You'll have to refer to the express documentation for that. Okay, and we are listening to port 3000. Okay, how do I start this? Simple, node, not sorry, node index.js. It's running. Let's test. 3000. Hello world, there you have it. Okay, uh so it's pretty easy. You can create as many paths as you want separately. For like for example, app.get slash about, another page about, okay, and then you need to restart your server, refresh, about, let's say I say, okay, so this is like express's own 404 page. Okay, you don't have to do it separate. You can do it, you can create your own custom 404 page, but let's say you haven't done that. There are things express being a framework does that for you. Okay, so coding becomes easy. So similar to this, you can even have app dot post if in case you want to handle the same URL but for a post request. Okay, we had the HTML page. I'll have to change the URL for that. Sorry. Cannot post. Okay. Why? Didn't we restart the server? Okay, now we have. I did not restart the server earlier. So you get the idea. Uh, data page. The home page. Getting started. Hello world. We covered it. Okay, so you get the idea. Yep. So I get this as JSON. I had to. Okay, so you can even use response. So response.send can be used to just send any string or HTML data. But when you say response.json and pass in an object, um, the page would parse it as JSON data. Yep. Also, you can verify the content type is application/JSON. So that's the MIME type or the content type for JSON. So Express did all that for you with just one line. If it was our old simple node code, we would have to set the header, send the JSON, and again, I can't just send a JavaScript object just like that. I would have to like convert it to string first and then send it, things like that. But here, just pass in the object and voila, your browser now. So this is basically how you would actually create a JSON REST API if you want. Create all the routes, do your query database thing, and then send the object data just by response.json, and your browser shows that, or whatever client you're using. Okay. You might have noticed that till now I was restarting the server manually again and again. If you don't want to do that, there is this utility, this tool called nodemon. If you, again, this npm package, if you just install it, okay, and then you start your application using nodemon like this. So nodemon, your file name that has the server. Okay. Anytime you change your code, the server will restart automatically. Okay, so try to use this along whenever you're developing. So to recap, we understood the HTTP basics, the basics of HTTP, request and response. We understood what HTTP is. It's a protocol for transferring hypertext, between a client and a server, or a browser and a server. The protocol was created, I don't know, more than 30 or more than that, many years ago. But then slowly and slowly people started creating browsers and servers. We have bunch of browsers, many servers these days running, but they all follow the protocol. Okay. We looked at the HTTP module in Node, how it lets us create HTTP server for us. Okay. For in other languages, let's say PHP, you use a server like Apache or Nginx. Java, I think you use a server like Tomcat. .NET, you would use IIS. But in Node, you can just write few lines of code and Node creates a server for you. Okay, so how cool is that? We looked at different frameworks of Node. We understood also that the request response thing that we use in the code, it's because the way HTTP protocol is created, any language that you use on the server, Python or PHP or Java, would have the same request response kind of thing going on. We looked at a bunch of frameworks that are listed in the Node website. but we chose Express. Good for starters, standard, very nice framework for creating web applications and REST APIs. Also, it's very popular because there are these two stacks called Mean.js and Mern.js. So Mean is basically MongoDB, Mongo Express, Angular, Node. Okay, so you only need to know one language, but then you can be a full stack developer and use Mean. You would need to know Angular, Mongo, and Node and Express, obviously, to use this and be a full stack developer. Or you can use, let's say, Mern, which is basically Mongo, Express, React, and Node. Okay, so very popular. Mean actually also is a contributor in the popularity of Express.js. So I hope you liked this session. We understood some important things today. So thanks a lot. Don't forget to like and subscribe. Thank you.